So this video will be the second video on anemia that I have made, and the first part went over how we can use the reticulocyte index to identify any kind of production issues, and when we do identify production issues, how we can work that up to identify what it is exactly that's causing the poor production of red blood cells and hemoglobin that leads to the state of anemia. Now, the second video is going to be going over when we find that the reticulocyte index is fine, thus we are able to narrow down that there may be a bleeding or destruction problem. So again, to go over the concept of anemia overall, it is the concept of accumulation equals input minus output, where if the situation is that we have low hemoglobin or a state of anemia, we have a low accumulation of hemoglobin, which means that either there is a low production or an increased output of red blood cells or hemoglobin. Now, if the reticulocyte index is appropriately elevated in the state of anemia, then we can kind of rule out that there's an input problem, and thus we have to turn our heads to the output issues, which include bleeding and destruction. Now, when trying to discern between the bleeding or destruction problems leading to the state of anemia, usually the bleeding aspect is pretty easy to spot, in that if you're able to get a history on the patient as well as a thorough physical exam, you might be able to more readily figure out that there may be a bleeding picture. For example, if the history shows that the patient is on any kind of anticoagulation or any kind of antiplatelets, that may increase the risk of patients bleeding. They may have some sort of genetic disorder that make them increase likelihood of bleeding. You may find on physical exam or from the history that they have been having hemoptysis, hematemesis, blood in their stool, or if they experience any kind of trauma that would have caused them to bleed a large amount, leading to a state of anemia. A lot of those things are things that you don't necessarily need to further investigate to be able to tell, hey, this person is bleeding. Now, it may become a little bit more difficult when we're met with the thought that there may be a increased destruction picture going on, because those things are a little bit more hidden, and we may have to rely on some labs to see whether or not that is the case that's leading to the anemia. So when we're investigating hemolysis, there are three big lab results that kind of help us discern, hey, is there a hemolysis picture going on here? And that is the LDH, the haptoglobin, and the unconjugated bilirubin. And we'll go over each of these and how the levels of each of these can kind of show whether or not there may be a hemolysis picture going on. So here I drew a little diagram to represent how these three lab values may change as a result of hemolysis happening. And we'll go over why the hemolysis is happening later, but first to see whether or not there is any hemolysis. Here we can see that you have some red blood cells on the left side here, and these red blood cells are filled with hemoglobin molecules as well as LDH molecules. These haptoglobin molecules are actually proteins that our liver produces that's able to capture any kind of hemoglobin that is loose and free in the blood. And albumin is down here, which is a general protein that's able to carry a lot of things in our blood, and we'll talk about how those things can come into the picture later. Now, for one reason or another, if we have a situation where the red blood cell lyses or basically pops open, of course, the contents of the red blood cells are released into the plasma, into the bloodstream, right? And we can see here that when the hemoglobin molecule is released, they can kind of break up into these dimers because it's a molecule that is made up of four globin molecules. And when it breaks apart, these haptoglobin molecules that are produced by the liver that I mentioned earlier captures these hemoglobin molecules, comes in and binds them together. Now, when they're bound together, macrophages are able to find these combinations and basically eats them up, processes them, and spits out unconjugated bilirubin. And these unconjugated bilirubins that are spit out get caught and are stored by albumin and brought into the liver where they're further processed. And while this is also happening, the LDH molecules that are also originally inside the red blood cells get released and thus increase the LDH level. So you can see how whenever we have hemolysis going on, we have more of these hemoglobin molecules released into the blood, which then cause a reduction in the free haptoglobin molecules in the blood because they capture and get eaten up by the macrophages. and then they produce more bilirubin, right? So effectively what happens is when we measure the haptoglobin level, it actually goes down compared to normal because they get eaten up by the macrophages. The unconjugated bilirubin level goes up because the byproduct of the processing and of the macrophages of the hemoglobin molecules, whenever they gobble them up, is an output of bilirubin. And the LDH that was inside the cell, this is the most straightforward, gets released, so it increases as well. Whenever we see this pattern happening within our blood, we know that there is some hemolysis going on. But at the same time, it doesn't necessarily show us why the hemolysis is happening. In order to differentiate the different reasons why hemolysis might occur, the way that I think about it is that I break it up into different categories of, is the red blood cell hemolyzing, as in breaking apart or popping because of the environment? Or is it because of something that is intrinsic to the red blood cell membrane? Or is it something within the contents of the red blood cell, as in the enzymes, that are deficient in some way that make it more likely to pop? And lastly, there can be problems with, for example, the hemoglobin molecules themselves, so hemoglobinopathies. So before going over each of these causes that I'm going to summarize, I just wanted to let you know that this is a very broad overview of hemolytic anemias, and technically if you were to try to go through them systematically, you'd be able to find that the way that people sometimes categorize these are things such as intravascular versus extravascular hemolysis, as well as, for example, the hemoglobinopathies. They may specify into saying if there are any kind of qualitative versus quantitative issues. Just keep in mind, those things are in the background, and if you were to go more thoroughly and robustly through the differentiation of those things, you'd be able to more systematically go through the different reasons, but I just wanted to give a quick overview. So for example, one example of an environmental thing is something called microangiopathic hemolytic anemia, where we have very small microvasculature, the microvascular arteries, where any kind of stresses that are strong enough to cause damage in the walls of the arteries can cause a out of control activation of fibrin and platelets to basically create these nets of essentially almost like barbed wire for red blood cells, such that when red blood cells come through, they get sheared across all of this and end up as a schistocyte. Another example of an environment/immune reason would be autoimmune hemolytic anemia, where the red blood cells have antibodies that are produced to fight against them by our body for one reason or another, and that causes our own immune system to basically cause attacks to our red blood cell and cause them to lyse. Certain membrane issues are, for example, hereditary spherocytosis, where there is a missing or dysfunctional protein within the cell membrane, which causes unstable red cell membrane and can slowly lose cell membrane to the extent that they become basically very small spheres. And those are much more fragile and likely to lyse as well. An example of an enzyme issue is something called, like, for example, G6PD deficiency, which is a common one that's tested on, where there is a molecule called G6PD which helps with oxidative stress, which helps the red blood cell deal with oxidative stress. But when there is a deficiency of that, any kind of, for example, medications that cause extra oxidative stress can cause the red blood cell to not be able to tolerate it, and as a result, lyse as a result of it. Hemoglobinopathies, the very common example of that is, for example, sickle cell disease, where the red blood cell membrane becomes very sickled shape because of the hemoglobin molecules that kind of chain together due to the mutation in the hemoglobin. Under certain conditions, the cells become very sickled, and if they become like basically permanently sickled or very, very stretched, the cell membrane can rupture very, very easily, causing hemolysis as well. For trying to tease out each of these things, it may be a little bit difficult, but for example, for microangiopathic hemolytic anemia, there are many things that can cause it, but a clue that this might be going on is if the platelet levels is going down, because of course the platelets are being consumed to create these basically barbed wires for the red blood cells. For autoimmune hemolytic anemia, getting something like the Coombs test will tell you whether or not there are any antibodies actually attached to the red blood cells that would raise your suspicion of autoimmune systems going on. Hereditary spherocytosis would be helpful if we get like a smear to actually visualize and see if there are any of these spherocytes present. Sickle cell disease would also be able to be identified with a smear. And G6PD would be a little bit more difficult to identify, and you'd have to kind of look at the medications that the patient's on, kind of the history and the pattern of the anemia happening. But a good evaluation of the patient's medications, as well as the proper timing of the evaluation of G6PD, would be very helpful. But in any sense, generally speaking, we can try to default to getting a Coombs test, as well as a smear, and maybe a evaluation of what medications the patient's on in order to differentiate amongst these types of examples. So in summary overall, if the reticulocyte index is appropriately elevated in the state of anemia, we rule out any kind of input issues, and we default to thinking, hey, is there any kind of bleeding or destruction going on? And we can really rely on the history, physical, and imaging to tease out whether there's any kind of bleeding issue. If we are suspecting any kind of destruction problems, such as the hemolysis examples that we were talking about earlier, we can use some labs with the LDH, haptoglobin, and bilirubin to confirm whether or not there is actual hemolysis going on. And with the hemolysis, we'll have an increase in LDH, a decrease in hemoglobin, a decrease in haptoglobin, as well as an increase in indirect bilirubin. And we'd be able to use tools such as the Coombs test, smear, or an evaluation of the patient's medications in order to try to tease out which of those causes of hemolytic anemias may be occurring.